Dear Director of Census Bureau, our purpose in bringing you this presentation here today is to compare two population projection studies that we have recently received. And we will be comparing the modeling approach, the projection structure, and the shortcomings of the models of these two population projection models as a way of reporting to you the results of our evaluation of these two modeling projects.
So let us start from the three factors in Toronto's model. Firstly, linear growth represents a consistent, steadily increasing population over time from 2000 years. Secondly, exponential growth reflects the impact of increases financial support of families, leading to exponential growth in the number of families receiving benefits and population growth. The last one, logarithmic growth, represents the influence of economic factors on population growth, wherein a gradual declining positive effect is observed as economic growth increasing by 3% annually.
Another factor in Hangzhou's model is linear growth. Despite a straightforward linear increase in population over time, considering the constant growth rates, which is 203 units per year, starting from the year 2000.
The difference is Toronto's model presents a comprehensive approach to understanding population growth by considering multiple factors such as economic, policy, and social influence. The model incorporates multiple components to represent various influence factors affecting population growth in a complex urban environment like Toronto. Toronto's model showcases its accuracy by comparing estimate population figures to actual data for past years. Accuracy demonstrated by a low percentage, 1.35%, when comparing estimate and actual population figures. This accuracy reinforces the model's reliability in predicting future population trends within a reasonable margin of error.
Hangzhou's model simplifies the model to linear function, focusing on the stable growth expected due to healthcare improvements and childbirth policies in Hangzhou. Additionally, Hangzhou's model forecasts the future population figures for Hangzhou, predicting values of 8,645, 9,660, 13,720, and 20,870 for the years 2025, 2030, 2050, and 2100, respectively. These projections suggest a substantial and consistent population growth in Hangzhou over the coming decades. The anticipated growth is attributed to rapid economic development and urban expansion, both identified as primary contributing factors to this trend. These predictions align with current trend and anticipated future development in Hangzhou, indicating a reasonable estimation of future population trends based on the model's assumption.
The limitation: Toronto's model might require extensive and accurate data for each component to accurately reflect the complex interaction among economy, social, and policy factors, based heavily on the availability and accuracy of data for each component. That may cause limited in its applicability.
Hangzhou's linear model relies on the assumption of stability in healthcare and policy without considering potential fluctuation or external factors that might disrupt this assumed stability. Hangzhou's linear model assumes a consistent linear growth trend, which might oversimplify the actual complexity influence in population growth in Hangzhou. However, relies on historical data and assumptions about future trends, which might overlook changes due to unforeseen events, for example, the pandemic or policy shifts. Critical thinking. Both models offer distinct advantages in representing population growth dynamics. Toronto's model provides a comprehensive view of Toronto complexity, but requires precise data and might be sensitive to assumptions. Meanwhile, Hangzhou's model simplifies predictions that might oversimplify the complex nature of population dynamic and overlook external influences. Balancing complexity, accuracy, and applicability remains crucial in leveraging this model for insightful predictions in urban population growth studies. Thank you for listening.